And so this is going to be my final solution to the standards. This one is for standard 38, and this is interference due to different indexes of refraction. And for this one, we've got two light waves. They begin totally in sync at a wavelength of 600 nanometers. And as they're traveling, the first one hits this area of diamond, which is going to essentially compress the wave and change the wavelength for this certain distance, this certain amount of time. And as it comes out, the theory is that it is going to be have a different phase shift than, or it's going to have the phase is going to be different depending on the index of refraction and this distance, and we're going to have either constructive or destructive interference. And for this one, it's not to scale obviously, but I've kind of illustrated some destructive interference, which is what we're going to be going for here. And to quantitatively find this out, I've set up this problem. I have taken the wavelength divided by the indexes of refraction. For diamond, which is what I used, it is 2.42, so we're going to go ahead and divide that. And this is going to give us our theoretical wavelength through this material. And for air, since it's so close to 1, I just went ahead and used just 1 and then just kept this basic wavelength here. And so after we find the wavelength through this section, we can find out how many how many oscillations these waves will do through this material. And for this one, we just take the distance up here of this area, this block of material, and then relatively this section of air. And we found that it's going to have 16.13 wavelengths through this material. And for air, we found 6.667. And to compare these, we can go ahead and take off the full wavelengths, because those aren't going to really matter whenever it comes out at the end here. And we can take just the decimals. So we can take 667 divided by, or not divided by, minus 0.13, and then that is going to be 5.37. So our phase shift is going to be 0.537 wavelengths. And that is going to be destructive, very destructive actually, since it is almost full half wavelength over.